Well, again, this video tries to help make a connection between the Planned Expenditures function and the Aggregate Demand function by showing you how the Planned Expenditures picture can derive points on the Aggregate Demand function, and we'll demonstrate the effects of a change in autonomous spending, such as a change in government spending or a change in investment, and we'll compare that to how the Planned Expenditure function represents a change in the price level. To follow along with this video, it's assumed that you have some familiarity with autonomous spending, the marginal propensity to consume, and the multiplier concepts. We'll start by looking at the graph and seeing we've got a planned expenditures function where autonomous spending is autonomous consumption, autonomous investment, autonomous government spending, and autonomous net exports. As drawn, I have those at approximately 3 trillion. And the equation for the planned expenditures function over here says that the slope is 0.5 times GDP plus the 3 trillion in autonomous spending. And remember that that 0.5 means that per additional dollar in real GDP or income, planned consumption goes up by half of a dollar. I also have a list of other variables here that we're going to refer to later. T is meant to represent taxes, so government taxes are $1 trillion. Government spending is 1.2 trillion. Investment is 0.4 trillion. I made up a variable called M that I mean to represent materialistic behaviors or some component of consumption, and that currently stands at 40, which really means nothing. And I'm also assuming that the price level is 120, and that will be represented later on the aggregate demand curve. Because the marginal propensity to consume is a half, we know that the marginal propensity to save is also a half, and the multiplier is always 1 over MPS. So here it's 1 over a half, that means the multiplier is 2. And that's shown in the graph as the ratio of the $3 trillion of autonomous spending and the $6 trillion of real GDP or of stuff that's demanded. And the ratio of those two would be 6 to 3, that's represented as the multiplier, or the autonomous spending is 3, and when you multiply that by 2, that's how you get the $6 trillion of real GDP demanded. Because in the planned expenditures picture, we assumed that the price level was 120, and with autonomous spending being 3 trillion, the multiplier was 2, and that meant $6 trillion of real GDP demanded. That means that the point 6 trillion and a price level of 120 is a point on the aggregate demand curve. The remaining question then is to decide what the demand curve looks like at other prices. We know that at higher prices the quantity demanded is going to be lower, and at lower prices the quantity demanded is going to be higher. But all that tells us is that the aggregate demand curve is downward sloping somehow. Using the planned expenditures approach, we could derive other points on the aggregate demand curve and then connect the dots and draw the line. To derive another point on the aggregate demand curve, we change the price level. So now we have the planned expenditures function, the red one, being 0.5 GDP plus 4 trillion instead of 3. So apparently, by changing the price level from 120 down to 110, we're assuming that autonomous consumption increases by $1 trillion. That number is completely arbitrary, I made it up. Notice though that the other variables, the tax variable is still equal to 1, government spending is still equal to 1.2, investment is still equal to 0.4, and the materialism variable is still 40. Because the multiplier was 2, we now see that the increase of autonomous expenditures of $1 trillion increases the level of GDP demanded by 2 trillion. The graph doesn't quite show that to scale, but the intersection there is meant to be 8. That means that our new point on the aggregate demand curve is $8 trillion at a price level of 110. So here on our picture of aggregate demand, we have the original point that we derived at a price level of 120, with $6 trillion worth of stuff being demanded. And at a price level of 110, we decided that the amount of real GDP demanded would be 8 trillion. So we draw a dot that represents that. That's a second point on our aggregate demand function. And we could continue to do this to derive many points on the aggregate demand function, or we can just call this good enough. We draw a dot between the two, and we say that the aggregate demand function looks like this. We know from the supply and demand chapter that the effect of a change in price causes a change in quantity demanded. A change in some other variable that affects buying or purchasing is shown as a shift in the demand curve. We'll derive how that shift works in aggregate demand by returning to the planned expenditures function picture. So now I've added a third line to our planned expenditures function. The equation for the green one is planned expenditures equals 0.5 GDP plus 5. That's $5 trillion of autonomous spending, shown as the y-intercept on the graph over here. Look at the list of variables underneath. I'm assuming that the price level has returned to 120, so you can compare the green function to the blue one, where the price level was also 120. I'm assuming that the tax variable is still $1 trillion of taxes. There is still $1.2 trillion of government spending. There is still $0.4 trillion of investment. And this M variable, which earlier I called materialism, it's just some made-up variable that describes consumption behavior. I've decided to increase that from 40 to 45. And the implication here is that compared to the blue line, autonomous consumption apparently increased by $2 trillion. So total autonomous spending, that is including governments and investors and net exports, although I don't have that included here, that materialism increased autonomous consumption by $2 trillion, from 3 to 5. Again, the multiplier is 2. So, oops, here we go. If autonomous spending is 5, that means the total amount of real GDP demanded is double that, thanks to the multiplier effect. And with the list of variables that we have, t equals 1, g equals 1.2, price level is 120, that list of numbers and that GDP demanded of 10 trillion defines a new point on the aggregate demand function. So we'll return to that picture next. In our graph of points along aggregate demand curves, recall the coordinates of the green point that we derived in the planned expenditures function. We said that the price level was 120, government spending was something, taxes was something, investment was something, the materialism variable changed. And because of that change in the materialism variable, we ended up with real GDP demanded of 10 trillion at a price level of 120. That means that this is a point, should be in green, there we go, on the aggregate demand function that we need to draw now. Compared to the blue curve, the thing that changed, that caused expenditures and GDP to increase, was not the price level. So we represent this new green point by drawing a new demand curve. And we've only drawn one point, but you can imagine what would happen, that the new demand curve looks something like this. And we can add some detail here by drawing an arrow that represents the size of the shift. Something like that. And we say that because of that change in materialistic behavior that increased autonomous consumption by $2 trillion, with a multiplier of 2, the increase in aggregate quantity demanded would be $4 trillion, and that's that length of the horizontal arrow. At a price level of 120, price level has not changed, it went from 120 to 120, but the quantity of GDP demanded increased by 4 trillion, and we'll write a little note for your reference there. So it's this change in a variable other than price. Could be the materialistic behavior, could be an increase in government spending or an increase in investment, and that causes a shift in aggregate demand curve. The planned expenditures approach allows us to derive the location of these points, and we just have to remember what we learned about changes in quantity demanded versus changes in demand to make sure that we represent those shifts correctly in the aggregate demand picture.